Hey guys, I'm Matt, a developer from Ohio, and in this video I'll be walking you through the Factorial feature project. To complete this project, you'll need to be familiar with JavaScript, the test-driven development cycle, Mocha keywords, and the Mocha test pattern. Let's get started. In this project, we're going to use test-driven development to build a factorial method. If you're not familiar with factorial, that's any number multiplied by every number smaller than itself. So, for example, 5 factorial, written as 5 with an exclamation mark, is 5 times 4 times 3 times 2 times 1, which is 120. Based on this knowledge, we're going to write tests that make sure a few specific inputs will cause our function to output the correct result. There is one edge case that isn't accounted for by this way of solving factorials. You might think that 0 factorial is 0, but it's actually 1. Honestly, I don't know why 0 factorial is 1, but it doesn't really matter. As developers, all we need to know is that it's out there, and it's something our code needs to handle. We're going to use the red-green refactor cycle to create our factorial function. That just means we're going to write tests that purposefully fail, and then we're going to write only the bare minimum implementation to get back into green. This process helps us make sure that our implementation does exactly what it's supposed to, nothing less and nothing more. So let's get into it. The first thing we're going to do is get into the red. This means we're going to write a test that fails. Because we know that 5 factorial equals 120, we'll add an it statement that tests if an input of 5 will have an output of 120. We're going to start with just this shell of our it statement. We'll write it, and then we'll follow that up with a descriptive message, something like returns correct value of 5 factorial, since that's what we're testing here. And then as the second parameter here, we'll have an arrow function like that. Now inside here, we're going to use assert.equal to check if an input of 5 has an output of 120. So we'll use assert.equal, and our first argument here is going to be our function, which is calculate.factorial with 5, our input. And then the second parameter here is our expected result, which we know to be 120. Now, we know we're going to get red, which means a failed test, because we haven't even made a factorial function. So just to make sure that we get our message back, we're going to type in npm test, hit enter, and we should see our message pop up because obviously we aren't returning 120. We don't even have a function, and in fact this says calculate.factorial is not a function. Now in step 3, we want to get back into the green, which means we want to write something that passes the test we wrote. We don't want to make our full implementation just yet. We want to do something that just barely passes. So we're going to go ahead and create our factorial function in here, and that's going to take an input number, in this case 5, expecting 120, and we're just going to return 120 just like that. Now when we come over here and use npm test, we should get passing because we do return 120 when you use 5 as an input. Before we go any further, we're going to refactor our test so that it follows the 3 phases of a good test, which are setup, exercise, and verify. Basically what we're going to do here is pull apart this assert.equal into its components. So we're going to make 3 variables. We'll start with the input number, which in this case is 5, and we can replace the instance of 5 down here with input number. Then we're going to have our expected result, which is 120, because 5 factorial is 120, and again, we'll just replace this. And under exercise, we'll get the actual result, which is our factorial implementation using the input number. And once more, we'll just replace this with result. Now we're going to write another test with an input other than 5, and this is going to force us to make an implementation that returns something other than 120 because the factorial of any number other than 5 isn't going to be 120. So we're going to add a second if block that checks 3 factorial. One of the benefits to using these 3 phases is that now we can just copy and paste this it statement and change the input number and expected result. we'll change this to 3, and 6, and I'll also change this message. And that's all there is to it. Now we have a second test that tests for 3 factorial with the result of 6. You can see that we do return the correct value of 5 factorial, but we don't return the correct value of 3 factorial, which gives us 1 passing and 1 failing. And here you can see that we got 120 when we were expecting 6. Now on to step 6, we're going to get back into the green by writing a real implementation of a factorial. We're going to replace our return 120 that returns the correct factorial for both 5 and 3, and as a result, pretty much every other number. Now, I've gone ahead and added my own implementation off camera. Feel free to use this implementation, use the hint under the instructions, or use your own implementation. The beauty of this system is that the implementation isn't what is important here. Because we're running tests, you'll always know if your implementation works. It's not as important how you get there. What really is important is that you're getting the right results out, which is exactly what we're writing tests to figure out. Before we move on to step 7, you should use another test to make sure that now your factorial method works. And this one does. We return the correct value of 5, which is 120, and we return the correct value of 3, which is 6. Now here in step 7, we're going to do a little bit of refactoring. If you followed along closely, you should be pretty good already, but we're going to run through just to make sure that your code is up to speed. So you want to make sure that you're using descriptive variables here, like input number and expected result. And you want to make sure that you're using these 3 phases: setup, exercise, and verify. And as you saw earlier, this is what helps us make new tests really quickly. We can just copy and paste this, make as many tests as we want, because it's set up and organized really cleanly. You can also refactor your implementation code. This one doesn't need so much work, but we can simplify it a little bit, maybe to make it a little easier to read. For example, we can change this to times equal. That does exactly the same thing, but you might argue that it's easier to read and therefore better. In step 8 here, we're going to handle an edge case. If you remember from the introduction, 0 factorial isn't actually going to be solved by our current implementation. And instead of writing in a way to solve for 0 factorial right away, because we're using test-driven development, we're going to write our test first. So we're going to add a third if block. We're going to write this just like our other blocks. We'll have a message like returns correct value of 0 factorial, and then we'll make a function. And inside of that function, we'll use assert.equal, and then we'll get our result, which is calculate.factorial, and in this case it's 0, and our expected result, which is 1 in this case. Now, when we run a test, we'll see that we fail the third condition, which is that we return the correct value of 0 factorial, because in our current implementation, we're actually returning 0 instead of 1. Now back to our index.js file, we're going to add implementation code that makes sure that this edge case also passes. Instead of doing anything to our existing logic, which works for everything except 0, we're just going to add an early escape that handles this edge case. So if input number is 0, then we're not going to do any of this at all. We're just going to return 1, because we know that the output for 0 is 1. The reason we don't want to meddle with any of our logic down here is because we're adding just the bare minimum to satisfy each test. And so this is the least amount of change we can make so that our code satisfies that new requirement. Now, when we run another test, we should get all green, because we still return the correct values for 5 factorial and 3 factorial. Those are untouched. But now we also return the correct value for 0 factorial, because we handle that edge case up here. The very last thing we're going to do is refactor our edge case test here so that it follows the setup, exercise, verify phases. I've gone ahead and done this off camera because you should be pretty familiar with the format up until now. In fact, it's exactly the same as we've done in our other 2 tests. The thing you need to focus in on here is that our input number is the number we're testing for is 0, and our expected result is the number we want to get out, which is 1. In this project, we used test-driven development to create a factorial function. By adding our requirements in as tests with descriptive messages, we were able to add exactly enough logic to satisfy the specification. We also handled a known edge case by first purposefully failing a test and then adding an implementation that allowed us to pass the test. Now that you're comfortable with test-driven development, you can use it to quickly and accurately implement features based on a set of requirements, as well as build a safety net that notifies you if something gets broken. I'm Matt for Codecademy. Happy coding!